Question 5a says, use the diagram below to prove the theorem that states that a line drawn parallel to one side of a triangle divides the other two sides proportionally. Okay, so the first thing we are going to do is we're going to construct a line from B to E, and then we're going to go ahead and compare the area of ADE, the triangle ADE, to the area of the triangle BDE. So it's going to be 1/2. The base we're going to choose for the big triangle, we're going to choose AD as our base. And then for the perpendicular height, that's just going to be then EF. For the small triangle, 1/2 multiplied by our perpendicular, our base. In this case, our base will be DB, and our perpendicular height will be the same, EF. So that cancels, that cancels, that cancels, that cancels, and we get the ratio of the areas as B equal to AD over DB. Okay, then we're going to compare the big triangle again, but this time we're going to compare to this small triangle. So the area of the triangle ADE with regards to the area of the triangle DEC. So we'll have half our base. We're going to use AE as our base, and for our perpendicular height, we will use GD or DG. 1/2 this side. For our base, we're going to use EC, and for our perpendicular height, we'll use DG. So these cancel out, and we're left with just AE over EC. But we can see that the area of the triangle BDE is equivalent to the area of the triangle DEC. Why do we say that? Because they have the same basis, right? EC and DB are equivalent to each other. Why do we say that? Because they are stuck between two parallel lines, meaning there's always going to be an equal distance between these two. So we'll say here that they have the same base because they are stuck there. So essentially we're saying that DB is equivalent to EC because of the parallel lines, right? So let's just write there, DE is parallel to BC. In that case, if these two are equal, and we know that here we're working with the same triangle, then we can say that AD over DB is the same as AE over EC.